Okay, hi everybody. This is the Math 31 integration review. This is question 7. A stone is tossed down with a speed of 8 meters per second. Okay, that means the initial velocity here is going to be -8. Okay, we're tossing it down from a cliff of 63 meters high. So our initial displacement is going to be positive 63. How long will it take to hit the ground and with what velocity? Well, we start a question like this with the knowledge that acceleration is equal to 1g. Okay, so -9.81 if you will. But we'll leave it as g for right now. We'll plug that in later here. Now we know that acceleration is the derivative of velocity. So now we're trying to figure out how long it takes to hit the ground. Essentially, I need to know when the displacement is 0. So we got to go from acceleration to displacement. So velocity is going to equal gt plus c. Okay, but we do have some initial information here. We know that if time is equal to 0, c must be equal to -8. So therefore, velocity is equal to gt minus 8. So we're able to use that little bit of information right there. Now we integrate again. Okay, or find the antiderivative to get to displacement. And displacement will be gt squared over 2 minus 8t plus c. Okay, that constant of integration. But we know that if we plug in 0 into this, and for initial time, we get a height of 63. So when we plug that down into that, and so we get s equals gt squared over 2 minus 8t plus 63. Now the question becomes, okay, when, for what value of time is the displacement equal to 0? Okay, so now I got to go in and I'm going to use the quadratic formula. Okay, now I'm just going to do this on my calculator here. So the quadratic formula is going to be the negative of -8, so it'll be plus 8 plus the square root of -8 squared, which will be 64, minus 4 times, now here's where this gets a little bit weird, 4 times a, which is going to be -9.81 divided by 2 times 63. Okay, then I'm going to divide that by, now 2a. Now in this case here though, a is going to be -9.81 divided by 2, so really it's just going to end up being -9.81. Okay, and if I press enter, I get t is equal to -4.5 seconds. Okay, which really doesn't make any sense. So now what I do is I go back up and I am going to change the plus to a minus in my quadratic formula to get my other root here, and I get an answer of 2.9 seconds when I round it. Now 2.9 seconds is the only one that makes any sense there, okay? Because the -4.5 indicates what happens prior to this experiment. Now the question is not only how long will it take to hit the ground, but with what velocity. So now what I do is I go to my velocity expression here, whoops, sorry, which you can't see, and that's going to be gt minus 8, and I will plug in my time, so g times 2.9 minus 8, so -9.8, whoa, sorry, I did something on the calculator that it didn't like, 9.81 times my answer from the previous question, minus 8, and I get that the answer is -36.1 meters per second. Whoops, whoa, you really can't see that. I don't know what happened there. So, and that makes perfect sense. Negative because it's going down here. So those two numbers are, again, very consistent with this question.